Okay, so this is how to do the graphs. Hopefully this will make sense. So we're using a pendulum here to look at. So here would be, well, I'm on eraser. Terrific. Okay, so here would be like the 0 position at the middle. Okay, this would be the X max. And over here will be the X min, some positive or negative position. Okay, so before you start, we'll start here. So this will be time equals 0. Okay, and then it'll be back at this point at time equals capital T, which is the period, right? Because that's one cycle. Okay, so over here, it would be half of the period. All right, and then it would cross this place here at the quarter and the 3/4. Oop, 3T. I gotta figure out my Apple Pencil. This is not gonna work. Okay. All right. So we want to think about these graphs. They're all kind of sinusoidal shaped in nature. Okay. And we want to think about the max and the min. Okay. So when we start, we're at the X max. All right. At half the period, we'd be at the min. Okay. And then we'd be back here at the half. At the full period. Okay. At the quarter and 3/4 points, right, I'm going to be crossing through the 0 position, so it's going to look sort of like this, okay? And we're going to get into the cosine sine equations probably next time, all right? But I just wanted you to kind of think about it for now, okay? All right, let me pause so I can get the next screen up. Okay, so this is the velocity graph, all right? So we want to think similarly about this graph, right? So when the pendulum, right, it's like here. Whoa, that's kind of bad picture. You get the idea. Okay, so here's the 0 position, right? So where is it going to be going the fastest, right? So when I start and when it reaches the highest point on the other side, that's going to be where the velocity is 0 because it's reached the highest point. So it's going to look like this, okay? As it crosses this 0 at the bottom of the swing, that's where it's going the fastest, all right? So we need to decide if it's up here or down here. All right, so we said this way is the positive direction. Okay, so if the pendulum bob is moving basically this way, in the X, we'll call it negative, okay? It's gonna have a negative velocity first, so it's gonna go down, it's gonna hit I guess I shouldn't have said minimum. Negative max would probably be better, right? Okay, and then it's going to go back up into stopped here. Okay, then it's going to hit its maximum velocity again here, but now I'm going in the positive direction, right? Because I'm coming back this direction, and then I'm going to go to here. Okay, and I wish I could see that other graph, but the position one was kind of like, let's see, it was this way, right? Whatever, okay? So if you go back to what you know about derivatives, etc., right, you're gonna think about at this t over 4 and here, these slopes are 0, okay? Well, I guess that's gonna be for the next one. Let me look at this one. Right, so this point here where it crosses the 0 should correspond to where it's going the fastest, okay? Because it's going to have the steepest slope here on the X, so it's going to have the greatest velocity value. Okay, same thing here. The steepest slope is going to have the greatest velocity value here. I guess we'll get to the slope of that on the next one. All right. Okay, so now we're thinking about the acceleration and the force. All right, so your acceleration and your force graphs, right, since F equals ma, these shapes are always going to be the same, right? Because whatever force you have is going to be directly related to the acceleration. Okay, so we want to think again about our picture. Okay, you can also look at the velocity graph and the slopes, right? Positive direction this way. Okay, so we're really talking, here's your forces, right? Your tension and your Fg, okay? But we're really talking about this component of the force here, right? Of the gravity force that's not, interacting with this one, okay? So when it's at the highest point, this tangential force is going to be the greatest, okay? And it's also pointing in a negative direction, okay? So that's going to cause a negative acceleration. Again, I should have just put negative, not min. Kind of dumb, okay? When it crosses through here, right, those forces are just going to be vertical, right? This one's going to have to be bigger because of the circular motion, okay? But there's not going to be any tangential force here. So at this T/4 position, that's where there's not going to be that tangential force, okay? So it's going to go like this. When I reach the other side over here, I'm going to again have that maximum tangent force, but now it's pointing in a positive direction. So that's going to be like this, like this, like this, okay? Force graph is going to look exactly the same as that because those are directly related, okay? Okay, and then the last would be an energy graph, potential and gravitational, okay? So again, here goes our pendulum. Okay, and I can't see them all because of the way I drew it, but take a little time and go through them and see how each graph relates to each other, right? Because there's a lot of questions about these graphs all the time, okay? All right, so this one's a little bit easier, right? When I have the, I might fix that. We actually don't want that either. I might fix those before you get this. Okay, so at the top of the path over here, at the beginning, right, you're gonna have the maximum gravitational energy, okay? And then when you come to that lowest position, it's gonna be 0. It's gonna max out again on the other side, back to the middle, back to this. So it's gonna be sort of this kind of shape, okay? The kinetic energy, right, at the first point, at the 0 position, okay, and the 0 time here, right, it's not moving, all right? It's moving the fastest as it crosses the bottom, not moving again at the other side, fastest as it crosses the bottom, not moving again the other side, okay? And none of these are going to be negative because the energy is really not going to be negative at all. Wow, that's a bad looking graph, okay? All right, so if you see this, you'll be able to see, right, the total energy is going to stay the same, and it's just going to fluctuate back and forth between, like if I superimposed the kinetic graph here, it would look kind of like this, right? Because it's just going back and forth, but that total energy is staying the same. All right, so take a little bit of time and just look through those graphs and make sure that you actually understand kind of how they're created, okay? And I might go back and fix that document.